Hello everyone, today we are gonna learn about Cauchy's root test from the module Infinite Series. So much we have studied, we have learned some of the methods to test the convergence of the series. So Cauchy's root test is one of the method to test the convergence of the series, of a given series. Cauchy's root test says that if summation xn is a series of non-negative terms such that limit n tends to infinity xn raised to 1 by n is equal to L, then summation xn is convergent if L is less than 1 and divergent if L is greater than 1. So that is, if we apply the limit n tends to infinity xn raised to 1 by n is less than 1, then the series is convergent, and if the limit n tends to infinity xn raised to 1 by n is greater than 1, then the series is divergent, and limit n tends to infinity xn raised to 1 by n is equal to 1, then the test fails. Now we can go through the proof of Cauchy's root test. That is, given limit n tends to infinity xn raised 1 by n is equal to L, then for every epsilon greater than 0, there exists k belongs to 1 by the definition of limit of the series. So by the definition, we have studied the definition of limit of the series. By the definition of limit of the series, for a given limit n tends to infinity xn raised to 1 by n is equal to L, then for every epsilon greater than 0, there exists k belongs to 1. So mod xn raised to 1 by n minus L is less than epsilon. When we remove the mod, minus epsilon less than xn raised to 1 by n minus L less than epsilon. That is, L minus epsilon is less than xn raised to 1 by n less than L plus epsilon. L minus epsilon whole raised to n is less than xn less than L plus epsilon whole raised to n. We can take this as equation 1. So now we consider the two cases of L. If L is less than 1, choose epsilon is greater than 0 such that L plus epsilon is less than 1. So let me take L plus epsilon as R, then R raised to n is equal to L plus epsilon whole raised to n. Then from equation 1, we get that x raised to n is less than R raised to n. Since if R is less than 1, we know that epsilon R raised to n is convergent. Then by using comparison test, summation xn is convergent. Okay. Then we consider the second case. If L is greater than 1, choose epsilon is greater than 0 such that L minus epsilon is greater than 1. Then we take L minus epsilon as P, then P raised to n is equal to L minus epsilon whole raised to n. Then from equation 1, we get xn is greater than P raised to n. And we know that if P is greater than 1, summation P raised to n is divergent. Then by using comparison test, summation xn is divergent. So how can we know that? How can we choose the test? How can we know that? When to choose a method? If a question is given, how to choose a method for finding the convergence, for testing the convergence? That is, if you want to choose a Cauchy's root test, we know that by seeing a question. That is, if the question is like some power of n, so when we take the whole raised to 1 by n of that equation of the series, we cancel the power. So next we can go through some of the example. That is, test the convergence of the following. That is, first one is summation 1 by 1 plus 1 by n whole raised to n square. We can take xn as 1 by 1 plus 1 by n whole raised to n square. So when we take xn raised to 1 by n, that equation becomes 1 by 1 plus 1 by n whole raised to n square whole raised to 1 by n is equal to 1 by 1 plus 1 by n whole raised to n. N square by n becomes n. So the numerator becomes 1 plus 1 by n whole raised to n. When we apply the limit n tends to infinity xn raised to 1 by n is equal to limit n tends to infinity 1 by 1 plus 1 plus 1 by n whole raised to n. And we know that we have studied that limit n tends to infinity 1 plus 1 by n whole raised to n is equal to e. So limit n tends to infinity, xn raised to 1 by n is equal to 1 by e. And when we give the value of e there, 1 by e is always less than 1. So limit n tends to infinity, xn raised to 1 by n is always less than 1. By Cauchy's root test, the given series is convergent. Now we can go through the second example, that is summation nth root of n minus 1 whole raised to n. The solution is given. We can take xn as nth root of n minus 1 whole raised to n, and when we apply xn raised to 1 by n, we get nth root of n minus 1 whole raised to n whole raised to 1 by n. N and n cancels, and we get xn whole raised to 1 by n is equal to nth root of n minus 1. When we apply the limit n tends to infinity, xn raised to 1 by n is equal to limit n tends to infinity nth root of n minus 1. Nth root of n we can write as n raised to 1 by n. Okay, so the equation becomes limit n tends to infinity n raised to 1 by n minus 1. When we apply the limit n tends to infinity for n, we get 1 by n. If n is infinity, n tends to infinity, 1 by n tends to 0, and therefore the equation becomes limit n tends to infinity n raised to 0. N raised to 0 is always 1. So the equation becomes limit n tends to infinity n raised to 1 by n minus 1 is equal to 1 minus 1. That is 0. 0 is always less than 1. So limit n tends to infinity xn raised to 1 by n is less than 1. That is the condition for convergence. So by Cauchy's root test, the series is convergent. And the third example is summation n equal to 1 to infinity n square by 2 raised to n. So we take xn as n square by 2 raised to n, and when we apply xn raised to 1 by n for the equation, which becomes n square by 2 raised to n whole raised to 1 by n square, and the numerator becomes n raised to 2 by n, and the denominator becomes 2. Okay, that is n cancels from the denominator, and we apply the limit n tends to infinity xn raised to 1 by n is equal to limit n tends to infinity n raised to 2 by n by 2, and the equation becomes 1 by 2 limit n tends to infinity n raised to 2 by n. And when we apply the limit n tends to infinity, if n tends to infinity 2 by n tends to 0, and n raised to 2 by n becomes n raised to 0, which tends to 1. Okay, which gives 1 value 1. Okay, therefore the limit and the equation becomes limit n tends to infinity xn raised to 1 by n is equal to 1 by 2 into 1, and that is 1 by 2. 1 by 2 is always less than 1. Therefore limit n tends to infinity xn raised to 1 by n is always less than 1, which is the condition for convergence. So by Cauchy's root test, the series converges. Thank you.